Hello, I'm the Mystery Mr. Daycock, and today I'm going to be teaching you about finding particular solutions to differential equations. Okay, so first of all, here's an example. Here's a differential equation, and the only extra bit from last video is this bit over here. It says, given that when x equals 4, y equals 1. So the process, for the start, is pretty much exactly the same. We're going to say we have dy by dx equal to x over y. I need to get the y onto the left-hand side. It's separable. It's a function of x multiplied by a function of y. In this case, the function of y is equal to 1 over y. But ultimately, that's still a function of y. And to get the y onto the other side, I'm going to multiply by y. So I get y dy by dx equals x. And then multiply by dx, not allowed, but still doing it. Dy equals x dx. And then we add our integral signs. So now we're going to integrate y dy equal to x dx. And this seems like it's pretty easy. It seems like this, if you think about it right now, it's pretty symmetrical. And the solution seems to be y equals x. But let's see what happens. We get here a half of y squared is equal to 1/2 of x squared. And then we can just multiply by 2. We get y squared equals x squared, and therefore y equals x. Nice and simple. Except, hopefully, you notice what I missed. At this point here, after we've done the integral, we need to put plus c on the end. And then here we're going to get plus 2c, which I can just call c1, the next a different c. But that very, very much changes this step. Because if I take the square root at this point, I'm going to end up with y equals the square root of x squared plus my c1. And hopefully you notice another thing, really it should be plus or minus. It could be one or the other, we're not necessarily sure at this point. Okay, now that is my general solution to this differential equation. My general solution is y equals plus or minus x squared plus c. And now I want to find the particular solution, and so I'm going to plug in these values here. I'm going to plug in x equals 4 and y equals 1. And I get y1 equals plus or minus the square root of 4 squared plus c. Or that's 1 equals, and in fact, looking at this, it has to be 1, and square roots are always going to be positive, and therefore we know it's the plus at this point. So already we've narrowed it down. 1 equals the square root of 16 plus c, and now I need to square both sides. And I get 1 is equal to, because 1 squared is 1, 16 plus c, and that tells me that c is equal to negative 15. And now I've got my particular solution. Y equals the square root, and remember we worked out it had to be positive from our initial conditions, square root of 16, not 16, this is x still, x squared minus 15, because my c value turned out to be minus 15. And that is a particular solution. There is only one curve that satisfies that equation. And so this is the single solution to this differential equation. Okay, similarly, another example. Find the particular solution of the differential equation dy by dx is equal to x over y. That is the same one. That is not meant to be the same one. I've done that twice today. Y over x, and when x equals 1, y equals 1. Okay, so we have dy by dx is equal to y over x, and we're going to do exactly the same thing. In this case, we need to divide by y, so we get 1 over y is equal to dy by dx is equal to 1 over x. Sorry, 1 over y times dy by dx is equal to 1 over x. And so 1 over y dy is equal to 1 over x dx. Integrate both sides, and we get the integral of y, 1 over y is the natural log of the modulus of y, and that's equal to the natural log of the modulus of x. Plus c, very important. And now let's get to y. So y is going to be equal to e to the power of the natural log of x plus c. And we could leave it like this, but there's some fairly easy simplification that can be done. Y is equal to e to the natural log of x multiplied by e to the c. Now if you write e to the c equals a, we get y is equal to a lots of, and e to the natural log of x is in fact just x. And the modulus lines have disappeared because those plus or minuses that we're not necessarily sure about can all be contained in the a. And so the general solution to this differential equation is the y is equal to just some multiple of x. And then let's take it up to, so that's our general solution, y equals some multiple of x. And so for our particular solution, we're going to have 1 is equal to a times 1, because we've got x equals 1, y equals 1, and that tells us that a is equal to 1. And so in fact, the particular solution to this differential equation is y equals x. Thank you very much for watching. That's how you find the particular solutions, not just the general solutions, of separable differential equations.